Thank you for coming. I'm glad that you choose to listen about evolutionary architecture with AWS Lambda. I would like to start this session with a question, and please raise your hand. So how many of you find challenging to evolve an application in the cloud? There are quite a few. Okay, I'm glad that I'm not alone. So thanks for that. Okay, let's start from this. So writing software is challenging, and serverless or containers, it doesn't matter. It's still a compute layer that is writing some software. And it's not easy, mainly because the business is evolving and requires often some drift on the way how we structure our code. And it's challenging. And one thing that I learned in almost 18 years in this industry is that there is a key characteristics in architecture, in software architecture, that could really help you to achieve the agility that your business is requiring. It's called modularity. And modularity, it can be expressed in architecture, but not only in architecture. It could be expressed inside your code, could be expressed in the infrastructure. But the key characteristics is the modularity. That will allow you, if handled properly, to move to the direction that the business would like you to move and your software to move very quickly. Today, what we are going to see is an implementation of modularity at the code base level, but not only, also at the infrastructure level. So we are tackling two levels of modularity. My name is Luca. I'm a principal solution architect in AWS. I'm an international speaker and an O'Reilly author. So what I want to share with you today is, first of all, understanding the problem, because we are engineers by heart, and we want to find new challenges to solve. And that's what we are going to understand today. Then I want to share the vocabulary that could be helpful for you when you get out from this session and you want to deep dive into hexagonal architecture if you want. So let's try to figure out deeply what every part of an hexagonal architecture means. We will see a code example. I prepare a code example where I will walk you through, and we will see how we are implementing with Node.js this application. Then we will see that hexagonal architecture is not useful only for a couple of use cases, but there are additional use cases, and probably I didn't even list all of them inside this presentation. And finally, we wrap up with also the possibility to download the code and then maybe review it later on. One thing that our CTO is used to say is that the software that we are writing right now is probably not be exactly the same that we are seeing in production in a year time. That's normal. It's called evolution, and that's also because, and that's also why I'm talking about evolutionary architecture today, because evolutionary architecture is just a mindset or a characteristic of your architecture that would allow you to evolve following the business needs. I think at least once in your career you have seen these architecture is a three-tier software architecture. We have a presentation layer, an application layer, and a data layer. And at the beginning, every application that we start in this way is well-written. Everyone is very disciplined to remain in their boundaries. You define properly everything. You go often to the whiteboard with your colleagues just to make sure that everything is polished and is working properly. But when you maintain a software developed in this way for, I don't know, 3 years, 5 years. People maybe are changing teams, people are moving to another company. And then you start to see maybe some leaks from the presentation layer to the application layer. Moreover, you can see also other leaks that are coming from the data layer into the application layer. So now evolving this kind of architecture is not that easy. And it's not the fault of anyone, right? So maybe there are developers from with different experience. Maybe they have to ramp up and understand better the domain. So it takes time. It's not easy. Another problem that I have seen and I experienced in my previous company is something like that. So we had some workloads that were running on ECS or EC2, and we wanted to move into Lambda. And at the beginning, especially if we take a container, we think, okay, that's easy. We just take what we have in the container, we put inside the handler of a Lambda, boom, it's going to work. Not exactly. And that's the main problem is not because it's the service that is wrong, it's the way how we structure our code that maybe is too tightly coupled. And therefore, extracting a portion of the logic or moving to multiple Lambdas can be a challenge. Then you start to think, okay, I want to move to serverless. And you start to research online, and maybe you find, let's say, some code like that. I omitted some code because it wasn't, let's say, meaningful for what I'm talking about right now. But as you can see here, you have a Lambda. It's a unique Lambda that you can find easily online, and you can find immediately that we are receiving some parameter in the body of this request. And then we call two functions. We call submit candidate P and this call it candidate info. And when we start to check what we have inside those two functions, we immediately see that we have a bit of information around the domain in the case of candidate info, and on the top we have submitted candidate P that contains instead information around which table, in this case DynamoDB, we are using and the characteristic of the table. So we started to mix and match inside this logic or inside this Lambda the business logic. We also mix a bit of the domain, we mix a bit of the infrastructure, and then evolving something like that, despite it's small, because today is small, but in 6 months time, who knows, is not that easy. So hexagonal architecture came to the rescue. And the creator, Dr. Alistair Cockburn, he was the creator of hexagonal architecture, but not only, he signed the Agile Manifesto as well. And the interesting part of this approach is that it's trying to figure out an architecture that would allow you to drive your business logic from multiple sources. It could be an automated test, a batch script, or maybe a request from an API gateway, whatever. Moreover, the other challenge that we have back in the days, but still have, but obviously with a monolithic code base is very relevant, is the testing in isolation, so the possibility to take a portion of your code and test it. Okay, let's try to discuss about the anatomy of an hexagonal architecture. So the first part, or the first layer, is the domain logic. There you have all the business logic that are related to, in this case, your Lambda function. So how your application should work in this case. And then you have the domain logic that is communicating with the external world, and the external world is communicating to the domain logic through the ports. And in this case, is a layer that is basically decoupling the external world with the domain logic. And finally, we have adapters. And if you're familiar with the adapter pattern, it's exactly that. So we are trying to take the information that are coming from the external world into the business logic, and the adapters are decoupled from the domain logic through ports. But let's try to understand, technically speaking, what ports and adapters are. So ports, this is a port, for instance, and we will see more in the example. So as you can see here is JavaScript. I'm not using TypeScript in this example or anything else, but the example basically what it's saying is we have a get stock data. It is a function that is just calling another function for related to an adapter. So in this case, this port basically is allowing the business logic to communicate with an adapter. There is no much magic, it's just literally decoupling between the two elements. If we want to see, let's say, a typed language, Java maybe, in this case, for instance, is another example, and as you can see, a port can be expressed as an interface. So if you have a typed language, a port is as simple as an interface. In the case of the adapter instead, we are wrapping the entire logic of a specific let's say, integration. So in this case is, for instance, the integration we have with Dynamo. As you can see here, I can read the entire integration that I have with DynamoDB for retrieving specific information. If I see the same thing in Java, it's exactly the same. But in this case, I have a Twitter account that basically is using my interface. Okay? So That's as simple as that. There isn't, let's say, too much complication on understanding ports and adapters. Okay, let's go back to our architecture. On top of these 3 layers, we have other 2 key elements, what they call the primary actors. And the primary actor is basically the one that are interacting with our Lambda function. It could be, I don't know, another service. It could be a front end, maybe through API gateway. It could be a message queue. And on the other side, you have secondary actors. So the one that are consumed by our Lambda for fulfilling a specific business logic. So it could be a database, it could be a service, it could be a message queue. So that is basically an anatomy of an hexagonal architecture. Obviously, as everything in architecture, there are always trade-offs. There isn't the perfect architecture, there isn't the best architecture, there are always trade-offs. And you need to optimize your architecture for the trade-off that makes your software successful. So the benefits of this approach is, first of all, that the business logic that is independent from the outside world. So you can independently evolve the business logic or the outside world, so the adapters, in the way that you prefer. Moreover, is encouraging the inside-out programming. And it's a style of programming that basically you start from, that is famous in test-driven development, that is starting from a component of your application and then you build up. But that component is testing end-to-end, is always working. And that is, let's say, a great way that we can enhance our software. It's easier to test in isolation. I can take just the business logic, test it without the need, obviously unit testing, without the need of testing all the adapters and other things. I reduce the technical debt. That is another challenge. I think it happened not only to me that more than once you have technical debt inside your backlog, but it's difficult to work in the next sprint. On the drawback side, what we have is that you need to build multiple layers up front. As you will see in the example, there aren't many. It's not that complicated. But if we want to see a drawback, that obviously will require a bit of logic and then trying to understand how to structure better your code. On the second point, the hexagonal architecture doesn't prescribe a structured business logic. So therefore, that could be a drawback, but also an opportunity. Maybe you have a good way to structure your business logic that you can use in order to have, let's say, a coherent and cohesive code base inside your applications. So by now, you're thinking, why hexagonal? We were used to work with layers, so why hexagonals? So the answer is coming directly from Alistair Cockburn. And the hexagonal is just a visual effect. We needed, because our applications were becoming more complex, we needed a way to explain and express ourselves visually when we were discussing with other team members. And we want to show all the interactions that a specific service could have. That is very true nowadays, I would say. Okay, so it's demo time. Before we jump straight to the code, I think it's useful that we all understand what we are going to see. So the first thing is, imagine this scenario, okay? So there is a team that is working on a stocks API. What they need to build is an API that is consumed by the browser, so by a client application, has to retrieve some information. Specifically, when the client is passing a stock ID, the API should return the value of the stock ID, in multiple currencies. And in order to do that, what we need is an API gateway, first of all. Then we have our Lambda, where we are going to implement our hexagonal architecture. And the Lambda will do two things. The first one is retrieving the value of the stock from DynamoDB. And secondly, is calling a third-party service for retrieving in real time the value of the different currencies that we need to apply to the initial currency, and then we return back the response to the client. So if we want to see in slow motion how the things will work, the request will come in, and then the adapter will pick it up. It will pass through the port to the business logic, the stock ID, and then the domain logic, as a first thing, through the port is saying, I want to retrieve in DynamoDB the stock value, and then it will call the currency service for retrieving the currency's value. and then it will return back the response to the client. So let's switch for a second. I take a picture because I didn't know the connection, considering yesterday was a bit flaky. So I take a picture of how it looks like. So this is basically what we are going to build. This is the response that we are going to have. OK, so let's jump to the code. So this is an example that I prepare. I will share with you later on the code. But as you can see here, we have few folders. We have adapters, domains, we have ports, so basically the anatomy of the hexagonal architecture. And we have our entry point that is our app.js. Can you see well at the bottom? Is it big enough? Cool. So in our handler, we don't have much. As you can see here, what we have is just, let's say, importing a module that is an adapter, taking the stock ID from the body, and then passing that to the adapter. That's it. We're not doing much more than that. Very simple. So when we go to the adapter, also in this case, obviously, I handle mainly the happy path. Obviously, if you have, let's say, also to handle all the errors, you can be more complicated. But I try to be simple just to pass the concept. So in this case, I have my adapter. And as we said, it has to communicate with the business logic passing the stock ID. But it cannot communicate directly, because otherwise we are coupling the two words. And what we are doing here is passing through a port the stock ID. So this HTTP handler is a port. So I go to the port. The port we said that in typed language is just an interface. In JavaScript with ES6, instead we are using functions because that's what we have. So in this case, we have stock. That is the module of our domain logic, and the port is just calling the right function inside our stocks logic. This is our, let's say, stock logic. So the business logic, as you can see here, is not, let's say, too complicated, first of all, but moreover, you cannot find anything related on the external world. It's literally business logic. If we read this code, what we can see is we retrieving some kind of repository, the stock ID, or better, the stock value, and then we retrieve the currencies, and then we prepare the response, and we calculate basically based on the currencies value, the value of the stock in multiple currencies. That's very simple to understand. I think is easy to follow as well. Now, let's try to drill down on what's happening here. So at the beginning, we have a stock value. And what we have in the stock value, we are calling what is called this module that is called repository. Repository is, once again, a port that has an adapter that is communicating with an adapter. And this adapter contains all the logic of the database. So if we fast forward a few months and the team, for any given reason, has to change the database in something else, they can atomically modify this adapter and nothing else, as long as the contract remains the same, obviously. But that's, let's say, by design, if you want. OK, so now let's move back to the business logic. Second step is retrieving the currencies. So on the currency side, we have still a port, and we have another adapter. It's called getCurrencies, this function. Here, I'm just calling directly, point-to-point, an API. And here, I receive from the third-party system its response, and I return back, and then the business logic will handle that. Great. And as you can see, every single part of my logic or my Lambda has its own module. It's not because I like create multiple files, but it's mainly because I'm following the architecture. So if I know that I need to interact with the external world, I will look inside the adapter folder. If I know that I need to change the business logic, I will go to the business logic. As you can see, it's very simple. So when you work collaboratively in a team, to understand immediately where to atomically put your hands and fix the problem, or let's say add a new functionality. Now, let's try to go ahead and play this scenario. Imagine that, for instance, right now, the service is in production, and we start to have a lot of requests, so really a lot of requests. We have a third-party service that is obviously integrated point-to-point, in this case, as you see from the code. And it might not cope up with the load. If you have like, I don't know, 1 million requests per second, probably the third-party service will start to throttle your request. So we need to change that. So the team goes back to the code, and it goes to, in this case, the port. So the control remain the same, and what we can do is changing the adapter. In this case, I obviously created a new one, but you can, let's say, evolve the adapter as you prefer. So in this case, what I have, I created an Elastic Cache cluster with Redis, and what I'm doing is applying the cache aside pattern. Cache aside pattern works in this way. First, we check in the cache if the value is present. If it is not, I'm going to call the third-party service. So here, once again, I'm wrapping all the logic that I need in order to accomplish this specific task. And here, as you can see, the first thing that I'm doing is checking if there is a currencies ID inside my Redis cluster and returning back the response. Otherwise, the first Lambda that is doing that is going to call the third-party service and then storing the data in the Elastic Cache cluster and then returning back the response. I changed basically atomically one portion of the application, changing the behavior, and I'm allowing you to evolve your application without touching the rest of the application. That is great. Okay, so now let's go back. Let me close a few tabs. Okay, so now let's go back to the slides. Okay, obviously we have seen that there are additional use cases. This is one of the many, right, that we can see. Let's start to see what we have available. So the first one is we can test the business logic in isolation. Because of this modularity, as you have seen, we can create a unit test that is testing only the business logic, and some unit tests that are testing only the adapters. The interesting part of that is that you can create a feedback loop for when you are developing locally that potentially you can split up those two occasions or these two use cases. How often are you going to change a database when you implement it once? Not much. But how often are you going to change the business logic? Very often. So potentially you can run the test when you are on your local machine, only your business logic, and when you are integrating with the rest of the application, you run all your full suite of tests. The other thing that you can have is, for instance, when you want to change a trigger with the Lambda. Imagine that, for instance, you have this service that is completely synchronous with the client, and you have API gateway, it's calling your Lambda. Now, at some point, you start to have a lot of requests, or maybe the product owner start to say, you know what, I don't really need to have a direct response. What I need to do maybe is a very complex computation in background. And what I need is that creating a polling mechanism or a socket connection, up to you how you want to handle, to the client in order to notify when the computation ends. So in this case, if we want to do something like that, we can have an API gateway that is adding the request on SQS directly. And then we need to change our logic, but not that much. Because we use hexagonal architecture, we have the adapter that is retrieving the information directly from the request from API gateway. And in this case, we just need to change the adapter to retrieve the same information, but from the payload that is coming from SQS. So another case where using hexagonal architecture really allows me to atomically change just a small part. Okay, another use case. When we want to add another trigger, imagine, for instance, that we have our application that now is using SQS. There is another team that is working in another flow and needs our Lambda. Okay, what I can do is creating a new adapter in this case for retrieving the information that are passed through EventBridge, because this team is using EventBridge. And once again, I atomically change just one part, that is the adapter. I'm not going to touch the rest of the application as long as the contract remains the same. Cache aside pattern, what we have seen before. I have a request from a client, or it could be another service, whatever you want. And then my Lambda first is going always to a database. In this case, not even a third-party service, it's a database. And you start to see that the queries that are coming are always the same, and you can cache them easily. What you could do is, for instance, using a cache aside pattern. So you basically you check first on the cache if the response is there, and if it is, then you just do the computation. Otherwise, you query inside the database. Another use case that it might be common, imagine that you have a self-managed application. So in this case, you're using your Redis cluster that is self-managed. And you spend time on updating the Redis cluster, maybe downloading a new version, patches, bugs, or whatever. And in this case, obviously, your team is spending time on not working on the business logic or evolving your application, spending time on fixing the cluster, database cluster. You want to move to Elastic Cache. And here it opens up a series of possibilities. Because when we want to migrate from a self-managed database to a managed service, in this case, what we can do is applying multiple patterns. For instance, in our adapter, we can, at the beginning, trying to have both of them and see if the response from Elastic Cache are the same from Redis. Imagine maybe that is not a service and not a cache service, but that's the idea. Or you can also implement branch by abstraction. So in this case, inside your adapter, you just write the code in a way that is seamless to transition. And when everything is done, you can fade out the Redis cluster in favor of Elastic Cache because it's managed. And now your team can focus on what really matters or where they can add the value that is basically your business logic. CQRS pattern, so common query responsibility segregation, is a pattern that is used especially when you want to scale your workloads. So imagine that you have your Lambda is communicating with Dynamo. And in this case, you have your adapter that is, let's say, writing directly from Dynamo, and another one that is retrieving the information from Dynamo, so getting the information from Dynamo. And that is fine till, unfortunately, you need to scale your workloads, and you need to rethink a bit your architecture. So how could you do that? Potentially, because we are using hexagonal architecture with modularize as our code, we can extract a portion of the code and create one Lambda for writing to Dynamo and one Lambda for querying or retrieving data from getting item from Dynamo. And that is another approach that using hexagonal architecture won't, let's say, create too many problems for you. Let's move to another, let's say, very concrete implementation. So web application modernization, so when you want to move your microservices to Lambdas. That's something that you can do. So let's try to see what the team have done before. So now let's imagine that we go back a few months from the team that was implementing the Lambda before. And what we have here is the same implementation. So we have, again, an hexagonal architecture implementation with adapters, domain, and ports. If you check the code here, it's exactly the same that we have in the other one. So I won't walk you through the code. But the interesting point is the entry point. So I'm using, in this case, Fastify. That is one of the many web frameworks that you can have for Node.js. And in this case, I have my get that contains my stock ID, similar to what we have in our Lambda. The interesting part, once again, is this one. The code that you can see here is exactly the same code that you have inside the Lambda. Now, let's imagine, and let's expand this scenario when we have a CRUD operation. So you have create, read, update, and delete. And you have multiple of those controllers that are implemented inside our container. So at some point when you are doing modernization, you can decide to do everything and define your microservice towards a Lambda. And maybe you want to decouple the different operations. So we have one Lambda for update, one Lambda for read, one Lambda for deletion, so on and so forth. But sometimes you don't have that luxury because maybe the time constraint or whatever it is. And potentially, what you could do is also saying, OK, let's try to review our traffic patterns. So I see that my service has a lot of read, but not many create, delete, and update. So maybe I can create, for the first step, so iteratively evolve your workload, just two Lambdas. One for read, and one for the rest of the application behaviors. And in this way, you are extracting a portion of the, for instance, just the read from your microservice, and then you can test it and start to see the benefit of that. And then when you learn from there, you start to do also the other operations. So you iteratively evolve your architecture in order to achieve, let's say, greater scope. And that, for me, is another benefit of using hexagonal architecture, not only inside the Lambda, but in general. If you're thinking, for instance, to potentially refactor a portion of your code, maybe thinking about hexagonal architecture could help you out. OK, so let's move back to the slides. There are many workloads that require hybrid architectures. So you need to have your architecture that is running in AWS, but also on-prem. So in this case, hexagonal architecture could help us, because what we can have is our Lambda, and then our Lambda is running in AWS. And maybe on-prem, we are using Kubernetes, but we want to use a serverless implementation of Kubernetes using Knative. Knative is the possibility to run serverless like we are running on AWS, but inside Kubernetes. We are developing with hexagonal architecture. Modularity is the key words here. And what we are doing is basically taking the same business logic and moving to Knative. So we are going probably to change the adapters, because maybe you're using a different database or different parts of the request. But there is a portion of your, and probably the most important portion of your application, that remain exactly the same. You deploy the same code. You don't have to tweak it and start to branch your code in a way that basically is forcing to test all the different situations. Am I on-prem, and therefore I need to test this specific edge case? Am I on AWS, and I need to test something else? That is another great benefit of approaching this implementation. So what we have seen so far is a combination of use cases, and we have seen an implementation detail of this architecture. But let's try to understand also what was at the beginning, because hexagonal architecture is not a novel architecture pattern. It's well known. In fact, it was created in 2005. So it's, let's say, a bit a while that is with us on developing these applications. Since then, there were some evolutions. So we have in 2008 what is called Onion architecture, and in 2012 you have the clean architecture. And probably some of you are just referring to hexagonal architecture to the clean architecture, but are three distinct architectures. And the interesting part for me is that Onion architecture and clean architecture are taking a very opinionated approach on the domain logic. So if one of the drawbacks of hexagonal architecture is that it was losing details, here with clean architecture and Onion architecture instead, you have a more rich, let's say, implementation that is divided in multiple ways. Now, the question is now, would you use something else for Lambda? I would say that the hexagonal architecture, if you structure a Lambda properly, should be more than enough. Onion architecture and clean architecture were created back in the days when monolithic code bases were quite common. I would say that also today there are quite few implementations of monolithic code bases, and there is nothing wrong with that, in my opinion. But it's very important that you don't over-engineering your code just because you want to use, I don't know, an Onion architecture or a clean architecture. Sometimes you hear that clean architecture and Onion architecture are exactly the same of hexagonal architecture. In theory, they are. They are based on hexagonal architecture, but they have their own, let's say, implementation details that are quite different. OK, so you have seen how hexagonal architecture works. You have seen how to implement that. You have seen different use cases. And probably the question that you have currently in your mind is this the definitive architecture for AWS Lambda? So any architect should reply to an answer, should provide an answer like, it depends. Because in reality, it depends from your context. It's not, let's say, me that can tell you, yeah, you must use hexagonal architecture. But there are some situations where it could help. And I give you some examples. Imagine, for instance, you are working on a SaaS project. So a software as a service that has to evolve, and you are going to, and you're working obviously with serverless, so with Lambda. In this case, you want to start your project, you deploy your project, and you start to have an evolution of this project with, let's say, additional features and, let's say, new team that are coming in, and maybe it's very successful. Yeah, probably in that case, using hexagonal architecture will save a lot of time in the long run. It's a good investment up front. But let's play another scenario. Imagine, for instance, instead that you have a project for an event that is going to run for, I don't know, a couple of weeks, and that's it. Or you are running, or you want to design a POC, proof of concept with Lambda. Probably using hexagonal architecture is not the first thing that you would do. It's very, very important, in my opinion, that you use the right tool for the job based on your context. And no one better than you can understand how your context works. So my suggestion is try to understand your context and understand if you want really to leverage the evolutionary characteristics of hexagonal architecture. So the key takeaways of this talk. So the first one is that we have a strong separation of concern between different layers. And that's great because, as we have seen, we can atomically change multiple parts without too many problems. The second one is the infrastructure is decoupled from the business logic. So I can really evolve, but also test new opportunities and very quickly understand if they fit for a specific workload or for a specific implementation that I have in mind. It becomes easy to test, especially unit testing. And that's great because it means that we can apply patterns like we have seen before, where I can create a very fast feedback loop for developers locally and then run the full test suite on my CI/CD. Finally, hexagonal architecture, as we have seen before, it was trying to solve a problem for monolithic code base when we have a three-tier architecture. But in reality, there are many use cases that could be solved thanks to that, because we are modularizing a code or structuring a code in a way that could really help defining our Lambda functions. Before we leave or we start the Q&A session, in this, behind this QR code or that link, you can find a blog post that I have written, is available on AWS Compute blog, that contains a detailed implementation of the example that I just showed you, and a GitHub repository that you can download the code and start to play with. And I hope that it will be helpful also for rationalize how you could evolve your application in the future. That's it for me. I hope that you enjoyed the session. I'm more than happy to answer any question. If some question will come up, let's say in the next few days or next month, you can just drop me a line. I'm more than happy to answer everyone. Thank you very much. Do we have any question? Yeah. So the question is why we are calling hexagonal architecture when at the end what we are trying to do is just modularizing our code and splitting in different places. The answer is basically the concept of the hexagon is coming for more designing on the whiteboard. So we are trying to divide and modularize the things and say this specific, in this case, Lambda function is being called by EventBridge, SQS, API Gateway, and those are the entry point, and you have more space than having just a rectangle for showing that integration. So don't be fooled by the shape. What you're saying is correct. So we are trying to just modularize our code, and is a way to structure our code in a way that will allow you to evolve your architecture in a proper way. The hexagon is mainly used for when you are designing your implementation at the whiteboard or in a diagram, wherever it is.
So
Okay, so the question is, now that we have those 3 layers inside our code, what is the bounded context of my Lambda? So that is taking a step back, right? So here what we have seen is looking at the implementation of our code and how to modularize our code. The bounded context, it could be that is representing one Lambda or multiple Lambda functions or multiple Lambda functions, right? Because the bounded context is a step back. So that could be a portion of the implementation of your bounded context. But then it depends how you are going to design using, I don't know, technique like event storming or general domain-driven design, how you're going to identify your subdomains, and then inside the subdomain, the multiple bounded contexts that are composing your subdomain. So that basically is just could be either representing a one-to-one overlap with your bounded context, or it could be that is a portion of your bounded context. Yeah, we will come back. We have time, no worries. So, yeah. Yeah. Yeah, so the question is what could fit inside an adapter pattern and what's not, right? Oh, where you configure, sorry. Yeah. No, you grab straight from inside the adapter. So usually you can be that you have, I don't know, you can use parameter store or secret manager, or you can use environment variables. It's completely up to you. But then it should be wrapped inside, let's say, the layer that is used. So, so if in this case, if it's the adapters, it would be the adapter. I think there was a question there. Yeah, so so the question is how you structure the code when you need to have a transaction with the database. So in that case, probably what I would do is expanding towards the adapter, because that is a matter between the external world and it's not, let's say, tightly coupled with the business logic. So if I start to leak the integration with the database, a specific database, towards the business logic, the risk is that you are coupling that word. So if you need to change the database, then it could be more challenge. So probably I will wrap in the adapter, because the role of the adapter, as the adapter pattern, let's say, states, is trying to change the communication between the external world and internal world in a way that the internal world understands the contract. Yeah. Then probably you need to structure, modularize that even further with more logic. Obviously, the hexagonal architecture doesn't prescribe you how big is the adapter. But unfortunately, when you have these kind of scenarios, you need to structure it with, let's say, your common sense. We have another question here. Okay, so the question is, what's the benefit of using ports, considering that it's just a pass-through to the next layer? The answer is you are decoupling basically two elements. So if you think that in reality the logic that is running is in the adapter for translating the contract and the business logic, if you couple them, then you are basically coupling the two words. Instead, the adapter, in the case of JavaScript, as I said, is just a function, so a pass-through. But in the case of a typed language, would be an interface. So at the end, the port itself is literally an interface. So it's even lighter. But in JavaScript, you don't have that unless you use TypeScript. But yeah, you're right. So it's exactly. Because that was implemented with Node. I didn't spend time on recreating with TypeScript, but yeah, that's the thing. Any other question? Oh, yeah, here.
I think the adapters let us go towards code sharing between multiple lambdas. You've got multiple lambdas talking the same thing.
Yeah.
Does that fit that you'd have a separate library with the adapters in that would get all in?
Okay, so the question is if the adapter, considering that are, let's say, well-defined and the encapsulation is pretty strong, can be reused across multiple lambdas, maybe shared in a library. Yeah, it could be. It really depends what you need to achieve, but potentially, yes, you can have that. And then with using lambda layers, maybe it could be a good way where you share your, let's say, part of the adapters, because obviously, if you create like a giant library with all the adapters, probably is not the best way to handle that. But yes, you can also do that.
Thank you.
You're welcome. Any other question? Oh.
So it seems that just by applying solid principles, we're very close to achieving a single.
Yeah, okay, so the question is, applying solid principles, we are very close to the hexagon architecture. To a certain extent, I would agree. The thing is, we need to understand how, let's say, we want to structure our code. Definitely, solid principle could help, and you are getting closer. Is it the same? Maybe, maybe not. So I think the interesting part, in my opinion, is that it depends. It doesn't depend anymore on the let's say programming paradigm that you're using, and it's more an architectural approach. That you have strong encapsulation, one strong pattern like the adapter, and then you basically create an anti-corruption layer between the external world and the internal world that is pretty strong, in my opinion, because when you are capable to do so, then you really, let's say, save time on how you want to handle your code base. Cool. Any other question? I think there was another one that you wanted to ask.
The last one.
Yeah, no worries.
Do we define a direction? Is it unidirectional the way things are going to go from one layer to another? For instance, can a code then connect back to an adapter to do something else? Or code from the main logic can go back to the code? It's kind of like splitting logic. So
Yeah, okay, so the question is, do we define a flow on how the, let's say, the callback or the call stack will work? Usually is very linear, and it's not, let's say, unidirectional, because at the end of the day, as you have seen in this example, I have two adapters on the secondary actors, and therefore I retrieve first one and then the second one. Potentially could run in parallel if you have multiple of those integration that doesn't have to be, let's say, run in sequence. In general, let's say there is a certain flow that is coming. So when there is a request that is coming in, you know that the secondary adapters, so the adapters that are handling the secondary actors are going to kick in, and then they don't come back. Because in reality, there is always this communication that is between business logic and an adapter through the port. And the only thing that when there is a request that the business logic does is calling back, providing the response basically after some computation. So the flow is very simple, and that's the other plus. Because if we think historically, one of the key thing for reducing the bugs in our code base, going towards unidirectional flow allows you to let's say, prevent that there is too much creativity in the code, and you immediately know where to spot the problem. Because we have like this differentiator between primary adapters, secondary adapters, and business logic, then also debugging the code becomes easier. Cool. Any more? Okay, so thank you very much for coming. I hope that you enjoy, and for anything, just ping me. Thank you.